Okay, great. I think I'll start. If there are seats available near you, please just raise the hand so that the other people who are still looking for seats are able to sit down too. Thanks. So the topic of this talk is simplifying Scala, the past, present, and future. It's a pretty broad topic, but I hope I can cover as much stuff and code and problems as possible. So first of all, welcome. I'm happy that you're all here. I will upload the slides after the talk as soon as possible. So if you search for the topic, for the title of the talk, you will find the slides too. So I'm Simon. I'm working on Scala for maybe 2 years, and in the beginning I was just complaining, and I think by now I got almost 200 bug tickets, and I decided that this isn't really what I want to do for the rest of my life. So I started to fix things and try to update a spec and hack the compiler, make the standard library smaller and stuff like that. And that's what I still do. And my goal is to make Scala a bit simpler and more consistent. So my focus is more on beginners' problems, not on the experts' problems, which you will also see later in the talk. And my motivation is to basically flatten the learning curve so that people can pick up Scala much more easily and much faster. There should be fewer pitfalls in Scala than there are currently. And in the end, if developers are happy, I'm happy too, because I'm also a developer. And in the end, I'm just building the language I'll want to use later if I look for a job. If you want to improve things, you always hear things like it's good enough. And often this is really the case for libraries, for application code. It's usually fine. But in the language space, it's good enough is often just not good enough. You must nail a feature down to 100%, or it will just break if people use it in unexpected configurations or something like that. And another thing people often say is, well, if it breaks, then just don't do this. And I really don't want to use a language where I have to keep looking for the pitfalls, where I have to avoid using certain features in a combination because they might break. And the last quote is, it's easy once you know it. And this annoys me pretty much because, yeah, sure, if I spend an infinite amount of time, everything is easy because I know everything, but time is limited. I prefer to spend as much time doing efficient things as possible and not wasting time with mistakes, bugs, design, oversights, and so on. So when I try to fix bugs or simplify the language, my approach is usually I consider the impact of the issue. Is it just an annoyance or is it a really annoying bug? I consider the frequency of the issue and how often do developers usually hit this issue. For instance, if it's a beginner's issue, do you hit the issue in the first 5 minutes of learning the language, then of course the priority of the issue is pretty high. And an important disclaimer before I start with mostly code is that I don't make any decisions. I only suggest things, maybe implement them, and if they are merged, I'm happy, but don't blame some changes on me because I didn't decide them. Also, I'm biased because I wouldn't have picked the examples if I didn't like the change. So maybe you disagree, feel free to disagree, it's perfectly fine. So let's have a look at the past. This covers mostly changes which are already shipping in the compiler. In the beginning, I had this really brilliant idea that I built this huge timeline and show how these changes are distributed over the timeline. But yesterday I figured out that all the changes are basically between July and 2013 and January 2014. So I picked those examples because I liked them, and I didn't really realize that they are all basically in the same year. So the first pitfall in Scala, which I really like, is unit insertion. Unit insertion means that the compiler looks for places where it can insert an opening parenthesis and a closing parenthesis to make code compile. It's a lot more complicated than that, but that's basically the high-level description. And if you look at these two lines of code, it says class foo of t, and it takes a constructor parameter value of t. And I try to write code like new foo. How many people in the audience think that this compiles? How many think that this doesn't compile? Okay. So if you look at this example, new foo, you basically start to wonder. A primary constructor argument is required, but none is given. So is there something implicit? No. Is there some default? Probably not. Does the type give any hint? No, absolutely not. So this compiles, and what the compiler decided to do is to basically interpret the line above as this. So there's a new foo, and because there's a constructor, it added the parenthesis for the parameter list, and because there was a value missing, it also added another pair of parentheses. And of course, the inferred type is unit, and so this compiles, and I think this is horrible. This is probably an example which is much more notorious and well-known. So this is the famous example where you call toSet with parents, and what happens is basically this. And so this is deprecated now, and this is deprecated in 2.11, and if everything works fine, will go away in 2.12. So the takeaway from this example is that we should really have simple and consistent rules, and these rules don't include basically guessing done by Scala C for us. It's fine that the compiler is pretty elaborate, but sometimes we just don't want that kind of thinking going on in the code base. So this, yes, exactly, this was deprecated in January 2014. Next example, floating point literals. If you look at the slide, there aren't actually any floating point literals on the slide. The reason is this: if you try to tell people about Scala, or if you try to get them interested in Scala, you often say things like, Scala is incredibly consistent, it doesn't have operators, it just has methods, and you can name these methods any way you want, and you can leave out the dot and the parentheses, and everything just keeps working. And that's the whole magic about things like 5 plus 10. And so people try out hello.jar at 0 and hello char at 0, and of course it works perfectly fine, and everything is consistent so far. So they go ahead and say, does this work the other way too? 1 plus 2 is an integer value of 3. So they say, okay, now let's use this method syntax, 1 dot plus parenthesis 2 parenthesis. Well, that returns a double. This is kind of inconvenient. And of course, it gets worse because if you add white spaces at the right place, you can make it an integer again. This was fun. I think I got gray hair over this. Again, simple, consistent rules, no guessing. This was deprecated in August 2013. No, this was deprecated before and was removed in July 2013. So I think the recent stable compiler, I think it's 2.11, should do it correctly. It should basically reject floating point literals where the digit after the dot is missing and always interpret a dot as a method, as the introduction for a method call. Okay, next things closely related to floating point literals are octal literals. So if you write 10, you get a 10. If you write 0, 10, you get an 8. And of course, it's easy once you know what's happening. They are octal numbers. It's completely obvious. The syntax is pretty common. There's no huge questions. There's no huge question what's happening here. But for people learning the language, something like this is really, really, really unintuitive. Additionally, because it only acts this way for integers, but not for floating point literals. And the even more obscure companion of octal number literals are octal escape literals, which you can basically use them to escape characters in strings, but only up to a char value of 255 or something like that. It's like completely pointless because we can just use Unicode escapes, and yeah. So we should really avoid having multiple ways of doing the same thing and avoid the potential for confusion. That said, it's really important because Scala is not a really, really simple language like a Lisp in many regards, to consider where we are spending our complexity budget of the language. So octal escape literals are currently deprecated, as far as I remember, in 2.11, and octal number literals are already removed in Scala 2.11. So this is a problem which is fixed too. So for comprehensions, a short quiz. Who thinks the first line compiles in a recent version of Scala? Okay. Who thinks the second line compiles in a recent version of Scala? Okay. The third line? Okay. And the fourth? Okay. This looks pretty great. So basically, the one and the first and the third example didn't compile since ages. And the second example is already deprecated and will be removed, so that we have only one consistent syntax for comprehension, which again helps people learning the language and also developers who have to read other developers' code, because there's only one true way of writing for comprehensions. I think all of this was already done back in 2011. So the present of simplifying Scala. There is a huge thing coming up. It's procedure syntax and its removal. So basically, what Scala says is favor immutability, avoid side effects, minimize state. But Scala also says, let's just give you this convenient shortcut to accidentally do the exact opposite. On code like this is really, really painful for people learning the language. I've supported another person doing a Scala workshop, and I think almost half the people fell into this pitfall by forgetting the equal sign. It's something which is completely obvious for people knowing Scala, but for those who don't know it, who don't know Scala yet, it's extremely frustrating if the code just doesn't do what they are expecting, and the error message isn't helping too. Related to procedure syntax is this declaration syntax for traits. This compiles. For those who don't know Scala, it's really questions. So what is def bar? Is it dynamically typed? Is it globally type inferred, like in Haskell? Is it something else? For those who know Scala, it's of course obvious that basically this is equivalent, but not for those learning the language. So method declarations without return type are deprecated too. And here the idea is that we don't have too many special cases. We don't need procedures and methods. Methods are working perfectly fine. It's just no benefit. There's just no benefit of having procedures. Also, we can avoid a bit of unexpected behavior. This means that people who don't know the language are not confused by this behavior. And of course, if it's dangerous, be explicit. And this means that basically everywhere where we are throwing away results, we now have to annotate it with :unit, which is a good thing, in my opinion. View bounds. How many people have used view bounds? Whoa. Okay, nice. View bounds are basically the unloved brother of context bounds and look like this. It's basically a less than % sign, and it says that we want to have an implicit parameter which is a function from t to ord of t. And Martin Dursky said a few months ago, basically, context bounds are essentially the replacement of view bounds. It's what we should have done from the start, but we did not know better back then. So to avoid using view bounds, we can either define a type alias, which looks like this, type odd view of t equals the function from t to ord of t, and then just use this type alias as a context bound. Or an approach which I prefer is just using an implicit parameter explicitly. So with both procedures and view bounds deprecated in 2.11, but still behind a future flag, there will be quite a few cryptic there will be fewer cryptic operators in the language in the future, and of course also less ways of doing the same thing. So this is in the present part because procedures and view bounds are deprecated, but to enable the deprecation, you have to pass another compiler flag to Scala C. The reason for that is that the IDE support isn't there yet, and I think it's pretty stupid to produce unnecessary work for developers if the IDE can just fix the code for us. So it will probably be deprecated officially in 2.12 and removed after that. Who knows? So the future, That's basically the part which mostly consists of my opinion. And my opinion is that it's horrible that we can't write code like this. We basically have a map with one value and want to map over it. And of course it fails because a map doesn't expect two parameters, but one parameter of type tuple2. And I think that's incredibly unfortunate, and both workarounds, either using this accessor syntax with _1, _2, and the case syntax are incredibly clunky. So I really hope that we can improve this in the future, to either recognize such situations or maybe just enable pattern matching by default in Lambda syntax, so that we can not only use parameters on the left-hand side of the Lambda, but arbitrary unapply methods. I think this would be nice. My personal pet peeve are lossy implicits, and basically most of the numeric implicits are lossy. So basically the conversion from int to float is lossy, from long to float is lossy, from long to double is lossy. And if you just imagine that the JVM or Java or Scala might get new number types in the future, maybe there will be a complex type in Scala or in Java. Maybe we will get an int with 128 bits of precision, maybe something else, and having these conversions which basically lose precision and change the way how the numbers behave is really, really a bad idea, in my opinion. So I hope we can get rid of that in the future, so that we have only conversions within the same number type. So if we have whole numbers are only converted within the hierarchy of whole numbers, and if we have floating point numbers, they are only converted in the hierarchy of floating point values. If you are interested in having at least a warning in today's compiler, you can use this compiler option -y1 numeric widen, and the compiler starts yelling at you if you write code like this. A situation which is currently pretty embarrassing, in my opinion, is the state of enumerations. We have basically three approaches. Scala enumeration, just search for enumeration in the bug tracker and you'll understand why using it is not a good idea. I don't know what to say about that type. I think we can't fix it. There's no chance this will ever work. The second option is a pattern which uses sealed trait and case objects, which is, I think, pretty common, but it's also much more powerful than enumerations in the sense of Java, where they are only a flat list of a known set of values. And the third option is, of course, just using Javac and writing Java enums, which will work perfectly fine from Java and Scala, which is another huge disadvantage when using either option number 1 or option number 2. So recently I sat down, or not recently, a few months ago, I recently sat down and used Eugene's impressive macro paradise and wrote a macro annotation called enum to see whether we could do better than the current options. And it looks like this. currently I think it's broken because I got a change merged into the Scala C where I thought it was fixing the issue, but now I have a different issue. But enums could look like this and could still be Java compatible. And this could be a nice option where we, on the one hand side, reduce the number of ways we can do the same thing, and on the other hand side, gain the convenience of having a way to write Java enums in Scala. Another point I'm always trying to make is about default imports. So the Scala spec specifies that certain packages or namespaces or types are imported by default. And for instance, that's everything in Scala, including the package object, everything in scala.predef, and the whole java.lang namespace. And two of these items are more or less quality checked. One of them is not. And it's basically java.lang, where we imports the whole namespace of java.lang, and there are tons of types which are either useless, like java.lang.float and java.lang.double, because they are permanently hidden by our own types, scala.float and scala.double, or just not interesting, like java.lang.void. We have types in java.lang which are completely broken. Java.lang.compiler never ever worked. It was supposed to give users control over just-in-time compilation, and there was one version where they said, well, it's not implemented yet, and in the next version they said, well, we will never implement this. And I think it's pretty sad that we have to deal with all these types. And of course, we have a lot of types which are not quite useless or broken, but types which are exposed in a way where they are really, really dangerous, like java.lang.thread. I can't use java.lang.thread. I certainly think that people who learn the language shouldn't get it offered in IDE completion when they try to write Scala code. I think this is a point which can be discussed, but in the end it would be nice if we could just get rid of the java.lang.star import and maybe selectively import individual classes from the java.lang namespace which are actually useful, like java.lang.class or java.lang.exception or java.lang.integer or something like that, and not the whole package with 200 types and dozens of sub-packages which clutter up the namespace too. Now to a completely different point. I spent the last months not working on Scala, but trying to make a Scala work on a different runtime. And I think this is a pretty interesting opportunity to have a JVM-compatible runtime which supports both just-in-time and ahead-of-time compilation and produces small native executables to run Scala code. And the opportunity here to simplify Scala is that we have support for proper tail calls and continuations in Avian. So if Avian was the only VM which we wanted to support, we could get rid of the code in Scala C, which does comparable transformations for us. And of course, Avian has a pretty small code base, so we could really start and implement features we are interested about, like value types or refi generics or something like that. We could just experiment with things and wouldn't have to wait until Oracle or Red Hat or IBM decides that it may be time to do something in Hotspot. So what's needed in Avian VM? For one thing, it's nightly testing. It would be nice to see if changes in Scala break code which runs on Avian, better SBT support to build Scala code directly to native executables. It would be nice to have pre-built artifacts of Avian available on the internet. I think the Avian people, Joe and Joshua, are working on that. They are doing incredible work on Avian. And one thing which would be really nice is an online compiler where you could just upload a jar file and get an executable for ARM64, whatever, ARM and all the different architectures back. So I think this could be a huge opportunity for us. Okay, enough advertisement. Of course, there are a lot of other things in Scala where simplification would be interesting, but I'll skip this. And let's just, I really thought about what can I say in conclusion to this talk, but well, simplifying Scala, there is a lot which has been done, and there is probably tons of stuff ahead of us which we can still fix, and I think we can do a good job of simplifying Scala if we just keep looking for those opportunities to simplify the language. So thank you very much. Questions? Yes. I'll repeat it. Ah, yes. The triple equals. Yeah. So the question is regarding the standard equality in Scala, which allows comparing things which are not really related to each other in the type hierarchy, like apples and bananas. Oh. Not sure which fruit you mentioned. So basically, the problem is that we have this hierarchy with any and any val and any ref, which have these methods magically. And I think it's really hard to get rid of it. I think it would be really, really interesting to push all these methods at least down from any to any val and any ref. I think some people have looked into that, and this would be basically enable us to write generic code which is safer than what we can write now. Because if we have some unbounded generic type parameter of t, then the upper bound is any, and if any doesn't have things like equality anymore, we can't use it in any weird way. And I think it's really a hard question. It's best if you ask again after the talk. I really have to think about it. It's like, of course, it should be done, but the question really is, how will the migration work? How can we move people to better code without breaking their code bases? And I have no idea how this would work in this case.
You fixed a lot of problems in Scala after the fact. Have you reflected a bit how to avoid that problems get into the code base beforehand?
From the language design perspective? Yes. Okay, so the question was, I basically talked a lot about fixing these things afterwards what can be done to prevent these language designs from going into the language in the first place. And I think there is not much help except a lot of experience. I see it a lot when new languages are invented, that they basically improve in one area which is interesting to the language designers, and basically ignore decades of language design knowledge in all other places. In the end, it only makes sense to look at as much as many languages as possible beforehand. So what I'm doing when I try to fix things or implement new features is basically I look what does Haskell, what does Idris, what does F#, what does C#, what does Java, what does C++, and try to understand why they either all did it the same way, or why some languages did it differently, and how these differences apply back to Scala. So I fear that the answer is we don't know much better than trial and error yet. It's, yeah, no idea. Sorry, who was first? Okay, first.
You mentioned you were trying to keep the Scala language spec up to date with the implementation. What's the status of that? And is there some automatic process or some process at all for keeping them in sync?
The question was how do we keep the language spec updated? And I was pretty annoyed about this because I had, I think, pull requests against the spec, which took, I think, 16 months or so to get merged. And things have recently improved because I think, I'm not sure if I'm pronouncing the name correctly, Arian McGinnis and Adrian Moores have converted the old spec from LaTeX to, I think, either Markdown or something else, and committed it into the main repository. So it should be more easy to keep the spec updated in the future. We, of course, have a huge backlog where the spec hasn't been updated to the latest compiler implementation. But I hope this will get the difference will get smaller over time, and the opportunity is certainly there. It's easily editable. There's now an online reference in HTML of the spec, so we can also read it much more easily. And I hope it gets better. But it's really it's a lot of work, and most people who are qualified to improve the spec have much more important work to do. And the things I'm doing is just small, easy things. I'm not a spec expert by any means. So, okay. After. Absolutely. The question was about the size of why I'm so bad at repeating what people said. The question was about the size of collection and array indices and the size method related to it. And absolutely, I share this concern. I think if the collection library will ever be redesigned, we will have to think about a better way of doing this. It will be possible to migrate the current collection library from integers to at least long, by just changing the return type from either size or length from int to long, and then just tell people to use either length or size if they want int or long as a return type. But I think to really get benefits from that, we have to do more work on it, because if we had 64-bit indices, we could have a really nice big array implementation based on that, where we can have arrays which are larger than 2 billions of elements. Paul Phillips has actually written a quite interesting collection implementation, where not only the size of the collection is tracked, but also the amount of knowledge about the size of the collection. So basically, we have sizes which say, well, I don't know the size of this collection without completely evaluating it, but I can tell you it's not more than 100 elements. And this is extremely interesting, and I really love to have something like that in the standard collection library. More questions? Yes.
Do you see the chance that type refinements could be made with abstract type members? So of anonymous?
Okay, the question is about type refinements and abstract members, and honestly, I'm not an expert in this topic. I can't comment on that. But if you're interested, there is a spec about the new experimental compiler called Dotty from the EPFL, and I think they have many changes related to how types and type members and things like this are handled. So maybe look in there and see if there are any improvements. Yes?
It's very exciting that there's some sort of an effort to port Scala onto a different VM, so this avian. But I guess, from what I'm hearing, the scope of this effort is rather weak. So I think the Scala community could benefit tremendously from having a better VM, right? And there isn't really, as you pointed out, there's very little movement on the part of Oracle and whatever, the VM vendors. So I think it should be something that's at the very forefront of the Scala community and consequently type safe.
Okay.
I wanted to make that comment and hear what you think about it. I mean, I feel that there's just perhaps there should be a huge fraction of people at type safe and maybe outside of type safe that are doing this work right now, because the benefits are tremendous.
The question is basically about the alternative runtime Avian, which I mentioned, and why there is not so much interested, or why there is not as much interested as there's not as much interest as probably necessary. And I perfectly agree with that comment. I think most of the work on Avian on the Scala side was done by me, and a larger part of the work on making Scala run on Avian was done by the Avian authors, Joe Dice and Joshua Warner, and they've really been great people and have been fixing bugs in an impressive fashion. And I really like to see that more people would see the benefits from having an alternative runtime where we maybe could implement things which are interesting for Scala but not for Java or not for other JVM languages. Even if the only result would be that afterwards we would know that feature X doesn't work that way, or okay, we have implemented feature Y on Avian, and it makes so much sense that we now are going to go to Oracle and tell them to implement it, please. So yeah, I agree. I think it's a really interesting topic, but yeah, I'm just a single person. I would really love if more people would be interested in it. Yes?
I'm a little ignorant, but this AVM VM already runs Java, but it has a different bytecode. What is it exactly?
Avian executes. Sorry. I repeat the question. The question was, how does Avian work? And Avian basically executes Java bytecode, and you can basically run every language on Avian which has a bytecode backend. So you can run Java on Avian, which was the original design or the original purpose of Avian, or you can of course run Scala on it. So. It's let's say it like this. I'm running the whole Scala test suite on Avian, and there are probably only a few failures where some things are done differently, like exceptions are printed slightly different. Like there's a test which checks that there are 3 lines of exception stack trace, that there are 3 lines of exception stack trace, and Avian prints only 2 or something like that. I think I'm really out of time. So thanks again. Oops.